This is exam to review part 2. This is question number 9. We want to graph the equation at h of x is equal to 6 cosecant pi over 4x plus 2 pi plus 2. So in this case, I'm not going to focus on cosecant. I will just imagine that this is actually sine instead of cosecant, because I know that cosecant is equal to 1 over sine. So I'm going to say the stretch factor, which is the amplitude, is 6. The period here is 2 pi because it's a sine, so it's 2 pi over b, which is b in this case is pi over 4. In other words, it's 2 pi times 4 over pi. That will give me 8. Pi will cancel with pi and we'll have 8. So the period is 8. C, as you can see here, is negative 2 pi. So this is A, this is B, this is C, equal to negative 2 pi, and D is equal to 2. So D is equal to 2. The horizontal shift is equal to C over B. I know that C is negative 2 pi over B, which is pi over 4, which is again going to give me negative 8. Negative 8 means it's 8 units to the left. So I know it's going to shift 8 units to the left. And finally, I need the midline. So the midline here is D. D is equal to 2. So now, before I find the asymptotes, I'm just going to go graph the sine function. And then based on the sine, I will determine my asymptotes. Or I can say I'm going to find the important points, and the important points are going to give me the asymptote. So the important points, you can find them by first dividing the period by 4. So I will have the period, which is 8, divided by 4. I get 2. So I'm going to start counting from 0. And then I'm going to add this number each time. So 0, 2, 4, 6, 8. I'm going to stop at 8 because that is my period length. So I have the 5 important points. What I can do now, I can basically add the horizontal shift or the phase shift here, which is subtracting negative 8 or subtracting 8. But I'm not going to do it this way. What I will do, I am going to create a new x-axis and a new y-axis, and then put these numbers on the new x-axis and the new y-axis instead. So I'm going to graph my vertical shift first. The vertical shift is 2, so, and the amplitude is 6. So I have to go by force, maybe. Let me go by 2. So here is 2, 4, 6, 8, 10, 12, and etc. Same for the bottom, negative 2, negative 4, negative 6, negative 8, and etc. I numbered this. Actually, this is not going to be my y-axis because the horizontal shift is negative 8. So I better start with the horizontal shift instead. What I can do, I can count by 2s when it comes to these. I need 8. I need 0 to 8. So let me see. 2, 2, 4, 6, 8. Yeah, that would work. So I'm going to say here negative 2, negative 4, negative 6, negative 8. The horizontal shift is negative 8 to the left. That means my new x-axis, my new y-axis, sorry, it's going to be this line right here. So instead of numbering this y-axis, let me just keep the number in here. This is negative 2, this is 2, sorry, 4, 6, 8, 10. This is here, negative 2, negative 4, negative 6, negative 8. Okay. Now I'm going to draw the vertical shift. The vertical shift is up 2 units. So it's right here. Make it a little bit better. Let me see if I can use this. Nope. Nope. Okay, let me try one more time. Okay, trying to move it up a little. All right, approximate. Okay. Okay. Notice how now this is my new origin. Let me just put a dot right there. This is my new origin. So if I want to put my important points there, I'm going to have to follow the same scale that I used at the bottom at the original x-axis. So that is what I'm going to do. Let me just make this a little bit bigger here. So here is the 0, here is the 2, here is the 4, and here is the 6, sorry, and here is the 8. All right. Now I know this is a sine function, meaning the first number is going to be a 0, skip the second, the third one is a 0, skip the fourth, and the fifth one is a 0. Meaning those are exactly going to be my asymptotes. And to find the rest of the asymptotes, you can just keep adding. You keep adding 4 to these, or you can subtract 4 from these. You can keep subtracting 4 from these to get the rest of the asymptotes. In other words, our asymptotes are going to be all of the x's such that x is equal to 0, positive and negative 2, positive and negative 4, positive and negative 8, and etc. So each time you're going to add 4. So now let me just focus on graphing the sine function. At 0, the graph is 0. At 2, the amplitude is 6. So 1 times 6 is 6. It has to go 6 units. So 2, 4, 6. At 4, it is 0 again. And then at negative 2, it is 6 units down. So 2, 4, 6. At 8, it is back at 0. So I am using the new points to graph. The old points to graph. I'm not using these numberings at the bottom. Okay, so here is the graph of sine, which is not exactly what I want. I need cosecant. Now to figure out cosecant, I am going to create the asymptote. So here is an asymptote. I'm going to just highlight it. And here is an asymptote. So each time sine is equal to 0, we're going to have an asymptote there. Okay, and let me just put a different color here. So here is an asymptote, an asymptote, an asymptote. Now to graph cosecant, I go to this point and then draw a parabola upwards. When I have a valley, when I have a mountain, when I have a valley, they share the same point here, and then I'm going to graph a parabola. One period is sufficient, or you can continue creating asymptotes and creating the graph of sine, and then put in the graph of cosecant in there. So to answer the asymptotes, we said this is 0, negative and positive 2, negative and positive 4, negative and positive 8, and etc. All of these numbers. To label the important points, this is the point 0 and 2. This is the point, you can see here, negative 6 and 8. This is the point this is the point, that's not negative 0 and 2. This is 2 units up. So this is negative 8 and 0. Negative 8 and 2, sorry. This is negative 6 and 8. This is negative 4 and 2. And this point here is negative 2 and negative 4. And this point right here, which is the original x-axis, this is going to be 0 and 2. Okay, so these are the important points that I mentioned before. You can just label them or write them here. Okay. Okay. The way you can find these, put your original points here, 0, 2, 4, 6, 8, and then we're going to add the horizontal shift, which is negative 8. So this gives you negative 8, the first one, and 2, negative 8 and 2. The second point is negative 6 and 8. And then this is negative 4 and 2. And then this 1 I'm missing one here. Let me erase the last one here. 6 minus 8 is -2, and -4. And then the last one is 8 minus 8, which is 0 and 2. So those are the important points. You either write them here or label them here. It doesn't really matter. The graph of one period of g of x is equal to 3 cosine theta over 2 minus pi over 2 minus 1. Sorry. So here I have to determine ABC. I see this is A is equal to 3. B is equal to, this is theta divided by 2, or 1/2 times theta, so it's going to be 1/2. C is equal to pi over 2, and D is equal to -1. So I'm going to start by finding finding the period and finding the vertical shift and the horizontal shift. The vertical shift is 1 unit down. So this is the first graph that I can start with. I can start with drawing that. Let me not label this, okay? So I'm going to find the period. The period is equal to 2 pi, because this is cosine over b, which is 1/2. That will give me 4 pi. All right, I have 4 pi now. I need to determine my horizontal shift. The horizontal shift, or the phase shift, is equal to c over b, and I know that c is pi over 2 divided by b is 1/2, which is equal to pi over 2 times 2, which is pi. So that is the phase shift. The vertical shift is 1 down. All right, now I want to find my important points. I'm going to say the period divided by 4 is equal to 4 pi divided by 4, which is pi. I'm going to start with 0, and then I'm going to add pi each time until I reach 4 pi. So 2 pi, 2 pi, I'm going to add this amount, 3 pi, 4 pi, and I know to stop because that is the length of my period. Now, 2 options. Either you're going to add the horizontal shift to each of these points. Let me add it. So, let me write them vertically so I can add it easily. 0 pi, 2 pi, 3 pi, 4 pi, and then the horizontal shift is positive pi. So the new points are going to be pi, 2 pi, 3 pi, 4 pi, and 5 pi. Now, most of the time I will not graph these points. I will just make a new x-axis and a new y-axis, and then I will use the original important points to plot on the new x-axis and y-axis. So let me just graph the new x-axis and new y-axis. The new x-axis is going to go down 1 unit. So if this is 0, this is -1, -2, this is 1, and this is 2, then this is my new x-axis. My y-axis is going by pi, so I'm just going to count by pi. If this is 0, if this is pi, this is 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, let's say. Then this is my new y-axis. And this is the new origin right here. So I can put these numbers on here using the same unit length. So here is my new 0. Here is the pi, here is 2 pi, here is 3 pi, here is 4 pi. Or I can use these on the original x-axis. It's up to you which one you use. Now, I know this is a cosine function, so at 0, it has to go up 1 at 1, but our amplitude is 3, so it has to go 3 units up. That means at 0, this is the 0, it has to go 3 units up. 1, 2, 3 units up. Okay, let me erase that now. Okay. And then I know that at pi, it goes to 0. And then at 2 pi, it has to go 3 units down. So it's going to be here at -3, -4. And then at 3 pi, it has to be 0 again. At 4 pi, it has to go up the same level at the first point. So it's going to go up 3 units. And this is the graph for cosine, like that. You see that I'm using the new x-axis and the new y-axis. I'm ignoring the old x-axis and the old y-axis. I'm not using them at all. So this is how you're going to graph this easily. You can always add the horizontal shift and then do the numbering on the original axis. But notice how this is going just to confuse you, because when you draw the 0, you tend to draw it on the original x-axis, while you should do it on the shift, on the vertical shift. And then you're going to label these points. So this point is 0. This point is pi and 2. This point is 2 pi and -1. Okay, let me do it here. So this is pi and 2, 2 pi and -1. And then 3 pi goes to -4. And then 4 pi is at -1 again. So -1 is the new 0. And then 5 pi goes to +2. And this is how you're going to label your points, and this is how you graph. One period is enough. You can continue the graph, but you can just stick to one period. Now, notice how we graphed the cosine function at the top. So easily, we can just say to graph this function, everything is the same. This is secant, this is cosine. We know that secant is 1 over cosine. So I can easily just plot my asymptotes here. So each time the graph crosses the x-axis, the new x-axis, I'm going to draw an asymptote. That is this line right here and this line right here. Okay, so 2 pi, 4 pi, I know it's going to happen again at 6 pi. So here is another asymptote. And I can finish this graph like this. And I know that it's going to happen again at this point right here. Okay. So now I can graph the secant, which is basically each time I have a mountain, I will have secant between the asymptotes. Each time I have a valley, it's going to be between the asymptotes. This is enough. This is one period. No, actually, this is half a period. This half with this half is 1 period. So I will just draw this one to complete it. And that's it. This is how you're going to graph secant from cosecant. It doesn't matter whether you graph it on this one or you do another graph, but let's determine now all of the asymptotes. Notice how the asymptotes happen at, if you look at the original one, or if you look at the original points, yes, you see that it happens at pi, and it happens at 3 pi, which is equivalent to saying it happens at 2 pi and it happens at 4 pi. So it's going to be all of the even multiples of pi. So if you look at the shift, it's going to be happening at 2 pi and at 4 pi. That means the asymptotes will happen at, the asymptotes are going to be all of the even multiples of pi, or you can write it x is equal to k pi, such that k is equal to 0, positive and negative 2, positive and negative 4, positive and negative 6, and etc. We know that the domain, if you look at the domain of the secant, you notice that the domain is taking all of the numbers except for the multiples of pi, all of the multiples of even pi. So here at 0, which is the original one, we don't have, we have an asymptote. At 2 pi, we have an asymptote. At 4 pi, we have an asymptote. At 6 pi, we have an asymptote. That means we're going to say the domain is all of the multiples of, all of the even multiples of pi. So we're going to say this is all of the x's such that x is not equal to n pi, and n is equal to 0, positive and negative 2, positive and negative 4, sorry, positive and negative 6, and etc. And then the range, if you look at the range of the function, you will notice that the range, the bottom, it stops at negative 4 inclusive of negative 4. So from negative infinity to negative 4, and then it starts again from 2 to positive infinity. So the range is going to be from negative infinity to negative 4, and includes negative 4 union, and then it starts again from 2 to positive infinity. All right. The domain should be similar to the asymptotes, exactly the same formula. On my notes, I have a mistake there, so just ignore the notes. All right. The next question, we need to find, or we need to graph cotangent. We're going to graph tangent, and then from tangent, we're going to create the cotangent. I will leave this for another part, so I'll see you in part 3 to finish the rest.